Is everyone. You are welcome to Jewel's Study World. Today our lesson will be on pi bonds or side-by-side or lateral overlap. So here we will focus on the PP overlap. What you have to note is that for PP overlap, it may be either sigma bond or halon overlap, or it may also be lateral or side-by-side overlap. It may be halon overlap or side-by-side overlap because you may have one p orbital here and one p orbital here. So these are p orbitals, but here they overlap head-on or they lie on the same axis. So here it becomes a sigma bond. But if they lie side by side like this with different axes, then it becomes a pi bond. So this is a pi bond between the PP and this is a sigma bond between the PP. So now let's continue. So for PP overlap or for sigma bond, you'll be focusing on oxygen molecule. So you have example, we have O2. So it means that you have two atoms of the oxygen here. So for oxygen, the configuration is 1s2, 2s2, 2p4. Then you have two of them. So you have another 1s2, so you have 1s2, 2s2, then 2p4. But our main focus will be on the last shell or the last orbital, which is the 2p4. So for 2p4, for the first one, you have the p orbital, you have 4 electrons in it. So 1, 2, 3, 4. For the first one, px here, py, then pz. And for the second one too, the 2p4, here is it. So you have px here, py here, and then pz here. So you have 4 electrons. So 1, 2, 3, 4. So now for this one, the overlap won't be formed between S and P, but it will be formed between P and P orbitals. So here, this py orbital will overlap with this py orbital, and this pz overlaps with this pz. So this overlaps with this, and this overlaps with this. And for them to be able to overlap, they must have opposite spins. So this must have opposite spin. The same thing applies to this one too. Opposite spins. So now since they have opposite spins and they are half filled, they can be able to overlap. So let's draw and see if they can be able to overlap. So for the first one, the 2p4, you have 1s2, 2s2, 2p4. For the 2p4 or the first atom, we have the py. Let's take this to be the py here, and we have pz. Let's take this to be the pz. So you have py, and then you have the pz. And for the second one too, we have py, and then we have pz here. So we have here to be py and then pz. So you have for the first one the py and then the pz. For the second one we have the py, then for the pz. So you have the orbitals here. And now we have here to be plus, plus, minus, minus, plus, minus, minus, plus. You have to note that for them to be able to overlap, they must have the same sign. So for the first one, PY overlaps with PY. So the PY here will have to overlap with this PY. But for this one, they overlap head-on. The overlap here is head-on overlap. And this will form a sigma bond. So we have head-on overlap here. So head-on overlap. So they have opposite spins. So here is it. They have opposite spins. So this will form a sigma bond. So they have head-on overlap here. And for the PZ and PZ, they have to also be able to overlap. And here the signs are the same. You have negative here and negative here. So they have the same signs. And they also have field. So they can overlap with opposite spins. And for the PZ, you have the Z here and Z here. So this will overlap with this one. This will overlap with this one. So for this one, they will overlap side by side, laterally. So this is PP overlap, but here it's for the sigma bond. And here too, PP overlap here, but here it's for the pi bond. Because pi bond, they must overlap side by side. You have 1P here, and you have 1P here. So these ones, they overlap side by side for the PZ here and PZ here. So this PZ and this PZ, they overlap side by side. And for the PY and PY, they overlap laterally here. Or axially here, because they lie on the same axis. But for the PY or for the PZ, they have different axes here. So it means that in the O2 molecule, we have one pi bond and then one sigma bond. We have one sigma bond and then one pi bond, because this will form a pi bond and then this will form a sigma bond. So you have a pi bond here between the PZ orbitals that will overlap. So it means that for oxygen, we have here's two atoms of oxygen. We have two atoms of oxygen. Two. We have 1, 2. So we have one first bond here. And note that the first bond in a molecule or in any bonding or in any bonding formula, the first bond is always a pi bond. So we have just pi bond here. It's always a sigma bond, sorry. The first bond is always a sigma bond, but the rest of the bonds are pi bonds. So since we have two bonds, so we have one sigma bond and the rest will become a pi bond. So let's check the next example. So our first example, we have the nitrogen molecule. So N2. So N2, what will be the bond or the overlap here? So let's check. So we have two atoms of nitrogen here. So we have, and the configuration is 1s2, 2s2, 1s2, 2s2, 2p3. And since you have two of them, you have another one, 1s2, 2s2, 2p3. But our focus will be on the valence orbitals. So you have 2p3 and 2p3. So you have the p, you have px here, py, then the pz. So for the first one, we have 3 electrons. So 1, 2, 3. For the second one, we have px, py, pz. We have 1, 2, 3 electrons. We have 3 here and 3 here. So these are going to overlap. We have px and px overlapping, and py overlaps with py, pz overlaps with pz. And for them to overlap, they must have opposite spins. So they must have opposite spins. Now they can overlap, and now they also have field. So let's draw the structure. So we have, for the first one, we have px. px, py, pz. So we have the x, px here, py here, and the pz here. And for the second one too, we have the px here, the py here, and the pz here. So you have the px, the py, and the pz. So here, the signs you have plus here, minus here, plus here, minus here. Then you also have plus here, minus here, minus here, plus here. You have plus, plus, you have minus, minus. So here, the px of the first orbital overlaps with the px of the second orbital. So for px, here's px and px. So you have pp overlap here. But for this one, they overlap head-on or on the same axis, and they have the same symbol too, minus here, minus here. So they can overlap. So they overlap head-on. So they have opposite planes here. And now they lie on the same axis. So this bond is a head-on overlap or sigma bond. So you have a sigma bond here. And now for py and py, so you have py here and py here. So these ones will overlap laterally or side by side. So we have overlap here, py here, and py here. So this is a pi bond between this. So for the px and px, we have sigma bond. Py and py, we have a pi bond. So because they overlap laterally, we have so px and px, we have px here and px here on the same axis. And also for py, we have py here. For py, we have py and py. They lie side by side. And then for pz, for the pz, we have pz here and pz here. So it's something like this, z here and z here. So this one too, they overlap side by side. They overlap side by side here. And also they have the same sign. So they must have the same sign. So plus, plus, then minus, minus. So here too, for the pz, you have plus and then plus. So this one too overlaps with this. This one too overlaps with this. So pz and pz is also a pi bond because they overlap laterally. So this one too is also a pi bond. So it means that in nitrogen molecule we have 3 bonds. So it means that we have 3 bonds. So nitrogen molecule, it has 2 atoms, but you have 3 bonds. 1, 2, 3. And now, how can you know the bonds? Note that the first bond is always sigma bond. So this first bond is sigma bond. And the rest are pi bonds. So you have pi bond here and pi bond here. So we have just 1 sigma bond and you have 2 pi bonds. So now this one, the first bond is sigma bond, then the rest are pi bonds. So in any bond, the first bond is always a sigma bond and the rest are pi bonds. This is how to identify the p orbitals for the sigma bonds and pi bonds. We will continue our lesson. Stay tuned. This is Jewel's Study World. Like, subscribe,